Okay, I know a while ago when I was doing those examples, I mentioned that we weren't doing domain, but that is something that I'm going to have to add back in. I had done those videos earlier, and this is something that needs to be added. So we are going to go back and discuss domain. All right, so of course you probably are familiar with domain, that we learned that as being our x values, but what that means is those are the numbers that we can substitute into a function, okay? And actually with this particular lesson, we're only dealing with two different functions. One of them would be a polynomial function. So the example that I have here is 6x cubed plus 9x squared minus 11. So this would be an example of a polynomial. Of course, you have dealt with polynomials multiple times. So when you're asked for the domain, in other words, you're asked what number can I substitute in for x and be able to work it out without, any issues happening. And with a polynomial, it's always real easy with your domain because you can actually substitute any real numbers that you want to. So here, that's why I have stated that the domain is all real numbers. So this will be your domain every single time that you have a polynomial. Now, the other type of function in this section that you'll come across is a rational function. And of course, the easiest thing to kind of remember there is you've got a fraction that's going to be involved. Well, the problem that you can have with rational functions is getting 0 on the bottom, because you cannot divide by 0. So if you plug in a particular number, it may cause you to have 0 on the bottom, which means it's undefined. So what you're going to do here is just simply take whatever the expression is that you have on the bottom, in this case x minus 6, and you're going to set it equal to 0 and solve it. So for this one, we're going to get x equal positive 6. So if I were to substitute 6 in here and here, of course that'd give me 13 on the top but 0 on the bottom, and 13 divided by 0 is undefined. So in this case, for your domain, you would have to say that it can be all real numbers except for that positive 6. So everything else but positive 6 will work for your domain. Okay, so what I want to do is, these are actually the problems that I worked for you earlier. So you can actually just go back and add this to the notes. So if you go back to where we had worked g minus f of x, and once we simplified this, we had x squared minus 5x plus 3. This is actually a polynomial. And because that is a polynomial, I told you that if it's a polynomial, that your domain is all real numbers. So you could go back in, or you do need to go back in and add this on your notes, that your domain is all real numbers. So let me just write this in here. If you want this in your notes, this is a polynomial. Okay, so because this is a polynomial, that's why we're stating here our domain is all real numbers, okay? All right, the second one that I have here, this would be one that is rational. Okay, so if it's rational, remember, you're going to take whatever it is that you have in your denominator and you're going to set it equal to 0. So that's what I'm doing here at the bottom. Of course, on this one, to solve this, what you're going to do is take square root of both sides. So square root of x squared gives you the x, square root of 0 is 0. Now normally, whenever you take square root of both sides, you put plus minus, but 0 is neither positive nor negative. So in this case, you would not have the plus minus. So that means that your domain is going to be all real numbers except the x equals 0, because again, that's the value that makes your denominator equal 0. And let's say we also did this one. Okay, so after we had done the multiplication, of course this is the answer here that we ended up with, and this is a polynomial again. And just as I told you before, if your function ends up being a polynomial, then that means that your domain is going to be all real numbers. Okay, So, like I said, you can just kind of add that stuff back into your notes that you had already written down.